All right, let's talk about slope now. When you are given slope on a graph, what they're asking you is how does this dot get to that dot? Okay, so that's what you have to find out. Okay, using rise over run. So it goes up 2, so it rises 2, and then it runs 1, 2, 3. It runs 3. And that's slope on a graph. I know. So let's do slope. What if you weren't given a graph? What if you were given a graph like this? Now the way that you do the slope when they give you 2 points, very similar to that level of difficulty. So the change in y divided by the change in x. Okay? So change in y. So how did it change? 5 goes to an 8. How did a 5 turn into an 8? It added 3, so positive 3. What the change in y? What about 2? 2 to a 1. How did a 2 turn into a 1? What was the change in x? The 2 turned into 1 by going down 1. Okay? So positive divided by a negative, that makes this negative 3. You could have also written it as negative 3 over 1. If one number is negative, it's negative. If both numbers are negative, it turns back into positive. But this is how you do slope when you're given 2 points. The change in y divided by the change in x. X, y, just in case you didn't know which one was x and which one was y. All right, next, functions. What are functions? For every x, there's exactly one y, okay? So every number you put in, every input has exactly one output. So let's say you have a chart, okay? These are the x's and the y's. So if I put in 2, the answer is 7. If I put in 3, the answer is 9. If I put in 4, the answer is 15. If I put in 5, the answer is 6. This is a function. This is a function. Every single x has only one answer. Now, if I add something like this, that means that 3 has 2 different answers. That is not a function. Not a function. Another way to display this is I can put it in coordinates like I just did, or I can put it as a mapping. This is domain, this is the range. So 5, 3, 1, 2, 9. So this is a function. 5, 2. When you put in 5, the answer is 2. When you put in 3, the answer is also 2. That's fine. When you put in 1, the answer is 9. That is a function. Now, if I were to say this, I'll draw with a red line. This is not allowed. This here, the way that it splits into 2. That means one has 2 different answers. That is not a function. Okay? When you graph, let's say I'm graphing something. Okay? If I go like this and go like that, this is still a function. Because if I choose x, if I choose this x, it has one answer. If I choose this x, it has one. Anywhere you choose, it will have only one answer. Now, if it looks something like this, okay, this is not a function. Why? If I choose this spot, it has actually 2 answers. If I do something like this, this is not a function. Why? Because right here, only one time, this one x has 2 different answers. It's not a function. Okay? So every x is allowed to have one answer. So that explains functions. All right? Rotation of 90 degrees. So we're going to pick a random dot. So let's say 4, 5. So I have chosen 4, 5. Okay, and this is x and this is y. Now, if you know how to rotate one coordinate, you know how to rotate any coordinate. It's very, very simple. You do have to know your signs. Okay, and this is positive, negative. So these are the coordinates in these quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So I'm rotating this 90 degrees. When you rotate the x and the y are going to switch places. Okay, they're going to switch places. So x and y are here. Now it's going to be y and x. So after our 90-degree rotation, the numbers are going to be 5, 4. But I'm not done yet because it matters where the sign is. If I rotate this 90 degrees clockwise, I'm going to end up in here. Okay, I'm going to end up somewhere in this area if I rotate this 90 degrees. Now that means that the sign has to be positive, negative, because it's in here. So that means the second number has to be negative. All right? Now, if I rotate this one number 180 degrees, so now let's rotate this 180 degrees. That means that x and y are going to switch because of 90 and then switch again. So guess what? They're back where they started. So with a 180 rotation, I don't have to change anything. Now I just have to figure out where it's going to end up. So this is 90 and then this is going to be 180. It's ending up in negative, negative. So negative, negative. So now the last one we're going to do is 270. I'm going to rotate this 270, which means, so this is xy. So if I was doing 90, it would be yx. If I'm doing 180, it's going to be xy. But if I'm doing 270, it's going to be back to yx. Every single time you go into a new quadrant, the numbers rotate. Rotation. Okay? So 4, 5. So in the first one, it was 5, 4. Then 180, it's 4, 5. So this is going to be 5, 4. So now I know it's 5, 4. But where did it end up? It started here, 90, 180, 270. Ended up in this quadrant, which means it's negative, positive. Negative, positive. And I'm done. I've done all 3 rotations. Okay? When you get this, you only have to do one of them. And it's usually to more than 1 point. But rotating 1 point is not as bad as you think. Okay, hopefully that helps. Next one, the angle, triangle, exterior angle sum theorem. So these two angles add up to that angle. So I know that x equals 70 because if I add these up, it equals 70. So the exterior angle is the sum of these two angles. It is not touching. So if I do something like 3x equals this, right? You're like, oh, well, now it's impossible. No, it isn't. 3x plus 40, 3x plus 40 equals, it should be a bigger number because this is bigger than these two put together. So let's make this equal 8x. Doesn't matter. So 8x. Okay, so these two, if you add them up, they equal 8x. Okay, so now look at this. I have too many x's. I'm going to get rid of one. Get rid of this one. Get rid of that one. So now I'm left with 40 because there's no more x's left on this side. I took away 3 x's from this side, which means I must take away 3 x's from that side, leaving me with 5x. Divide by 5 on both sides. 5 divided by 5 is 1. How do you write 1x? Like that. Whatever you do to one side, you must do to the other. 40 divided by 5, that leaves me with 8. Okay? The distance formula. How far is A from B? Now A is at 1, negative 1. B is at 8, 1. Okay? Now, I'm going to show you how to do it on here. So all you have to do is find out, you have to make a little right triangle, and now you can make Pythagorean's theorem. So from here to there, if you count the boxes, 1, 2, 3, 4, 5, 6, 7, and then you go up 2. So this is 7, 2. So this is, the way you figure this out now is a squared plus b squared equals c squared. 7 squared plus 2 squared equals the distance, which will be c squared in this scenario. Okay? So a squared plus b squared equals c squared. So 49 plus 4 equals c squared. So my answer is 53 equals c squared. But I didn't want to know what c squared means. I want to know what c is. So I'm going to square root So my answer is the square root of 53 equals C. All right? Now I'm going to show you how to do that without the graph. What if you can't make a right triangle? What if you're doing this? Very similar to what we did before with slope. Okay? So now we just have to figure out how far is -1 from 1. Well, they're 2 away from each other. 2 squared. Plus, how far is 1 away from 8? Well, they're 7 squared. Look at that. I got the exact same numbers. On C squared, we'll do C squared over here. How do you get rid of the squared? You square root. And there's my answer. Same answer, different methods, because they're both the distance formula. Okay, and then I think that is it. Good luck, everybody.